Hi, everyone. Thanks for being here. I thought we'd take a little time to talk about a subject that I feel is very important, but probably doesn't get enough attention. And that's on the subject of technical debt. I believe that in this new era of Gen AI, as we all find new methods of creating software and building systems, that there are a lot of things that we need to consider and that we need to learn about and share with others. And I think technical debt is one of those topics that we certainly need to make sure that we are talking about and sharing with other people. So that's what we're going to take today's time to discuss. Now, for those of you who are not familiar with technical debt, here I've got the Wikipedia definition on the screen for us to go through. Technical debt, quite simply, is just another way of describing some of the implied costs, or as it says here in the Wikipedia entry, the implied cost of additional work in the future resulting from choosing an expedient solution over a more robust one. Now, I'm going to, I think, just add a little bit more color to this in that it's not always simply about expedient solutions over a more robust one. I believe that there's actually a little bit more to that, and especially when it comes to Gen AI and some of the things that we have available to us and a lot of the techniques and tools and just the new things that we have to think about. And so while this version of technical debt I think is great, I think one of the other things that most of us want to get to when we start talking about technical debt is what are the causes of technical debt? And therefore, how can we avoid that? So if we pull up Google here and just say, what are the top causes of technical debt? And we'll see what the results are for that. We can see here, it's going to give us some AI generated explanation of what the top causes are. It says that the tight deadlines and rushed development is a top cause. Poor code quality and architectural design is a cause. Again, here you can see it's referring to rushed development, lack of code reviews, or in other words, bad code quality. Insufficient testing, which I would also put under code quality. Lack of documentation, again, probably a code quality type of thing. And then down here, they've got a few other sort of larger ideas around technical debt related to lack of documentation, knowledge gaps, security vulnerabilities, insufficient testing, all of this kind of stuff that maybe you're familiar with and you've talked about and had discussions about. But what I would like to, I think, get you to think about in terms of these things is if these are the causes of technical debt, if insufficient testing is the cause of technical debt, if lack of documentation or security vulnerabilities are the cause of technical debt, what is the cause of those things? And so what I want to spend the rest of today talking about is two things. First of all, let's actually talk about technical debt. I've put together a little visual demonstration. I'm a visual person. For me, that is the easiest way for me to understand most topics. And so I put together this, what I call a disposable web app, to help visualize and understand technical debt, maybe in a different way that might make more sense for me, and then maybe even for some other people too. Technical debt is just what I like to think about it in terms of what are the top causes and what are causing these things, what's causing insufficient testing, what's causing security vulnerabilities. I often will boil it down to three different areas. And that's going to be speed, cost, and safety or quality. You can put those together. Now, those three areas I typically think of as barriers that oftentimes we are forced towards, or maybe some sort of horizon line that we're often forced towards, or bounding box that we're forced towards. And if we keep it in real simple terms of just those three areas, speed, cost, and safety/quality, we can start to see how we can get out of balance and start to create technical debt. Now, obviously, this is a very simplistic model in terms of what software development is like these days, and things have changed quite a bit. And you can make a very good argument that there are many more correlations or contributing factors to technical debt, and you're absolutely right. But when it comes to these three, I think they probably best encapsulate a lot of the other things that people usually bring up when we're talking about technical debt. So stay with me here when we're talking about speed, priority, cost optimization, safety and quality, and then how that affects technical debt. Okay. So now let's just use a little bit of a hypothetical situation here. Let's say that you are a startup. Now, most startups are very much focused on high velocity. They want to be able to build very quickly. They need to get feedback from their users. They need to then develop new solutions and take that feedback from their customers and just get to market very quickly. So they have a lot of focus and priority on speed. And so you'll see oftentimes they will prioritize on rapid delivery and possibly take shortcuts because they're able to be risky and take those types of shortcuts. They need to take those types of shortcuts in order to be agile, in order to be able to get ahead of the pack. Another area that you'll see startups often make changes that don't align with something that's maintainable with technical debt is that they will oftentimes use minimal resources and cut corners as opposed to maybe having a high investment and using high-end premium tools. Oftentimes you'll see them cut corners, like I said, and try to save where they can. Again, that's just the life and the DNA of a startup. And then when it comes to safety and quality, you might see that they've also got some different standards when it comes to quality control of their software. Maybe they're not doing extensive testing and have robust designs. Maybe they're just down here somewhere where their quality practices are just the bare minimum. They're not necessarily taking shortcuts, but they're somewhere in here, okay? And when you can see how that adjusts the technical debt numbers here as somebody decides to spend a little bit more time being a little bit more balanced with their delivery pace as to maybe being a little bit slow with their delivery pace and being thorough. So that's the life of a startup, right? And on the other side of the spectrum is the enterprise, where they're going to be a little bit more balanced in their delivery pace. It's not super slow. It's not necessarily always thorough. They're somewhere in here. And then cost optimizations. They're not necessarily cutting corners and trying to save pennies wherever they can. They're somewhere more in the middle, more moderate. And then when it comes to safety and quality, they are being a lot more extensive and putting in some more robust designs. However, this extreme focus on safety and quality, it comes with some trade-offs, and there will be some technical debt that comes along with that. The system's going to become unmaintainable unless these developers can find ways to find a little bit more balance between what they're doing between speed, cost, optimizations, and safety. And then one more example here would be a bootstrapped budget where, again, it's a little bit more balanced here and moderate in their pace of delivery, but they are cutting corners and really saving wherever they can. Like I said, it's a bootstrapped situation, so cost is a big concern. They are just following best practices when it comes to quality. However, that high focus on cost optimizations is going to cause some sort of unbalance in their technical debt at some point. There's going to be some sort of interest that they're going to have to pay. That's really just the super simplified model that I wanted to share with everybody when it comes to technical debt. Now, there's two other things that I think personally we do need to think about in the cloud development worlds these days, and that's maintainability and scalability. Those, I think, are two other areas, I'll let you read that, where now it's not just about cost, it's not just about speed, it's not just about safety. And those three, if you boil it down, I think now we also have to think about maintainability, and scalability has two other vectors in the technical debt space. And although I don't have those here in my model, I do think that is something that we should consider as we start to think about technical debt and how it is playing a role in some of these new web applications that we're building. And at the pace in which we are building things, I think it's super important for us to consider that. So those are the main things that I wanted to share with you today, really just to get you thinking, because it's something I've been thinking about lately. I took some time off and haven't written any applications, any web apps, any disposable web apps for over a week. And during that time, I actually got to thinking about how quickly and rapidly I'm building things and what are the possible negative downsides to building quickly. And of course, technical debt pops up right at the top of all of our concerns. I'm obviously building things very quickly, very rapidly. I have began, as I mentioned in a previous episode, instrumenting most of my applications for both understanding how the application is working and how I can improve it and that kind of thing, but also just understanding the usage and that type of stuff. So I'm starting to think in those types of ways, but I'm now also starting to think on some of these projects that are actually beginning to take shape and need a little bit more than just a vibe coding hour or so, technical debt is something that really has to be considered. And for me, it comes back to really thinking about and considering how quickly do I need to do something? What are my costs associated with it? And do I need to either consider cutting costs here and there, or also the safety and the security stuff? Those are just more concerns too. But before we go, I wanted to show you one more thing, really just how I created this visualization, because it's something that I've been doing here a lot lately. Like I mentioned, I'm a visual learner, and oftentimes when I learn about a subject, I read about something, hear about something, whatever the case may be, I will often go, what a lot of us will do, go on to the internet and try to search for it. But lately, I've had a lot of fun actually just turning to a variety of different LLM tools. The one I used in this particular case is Claude. One morning, I was just thinking about technical debt, like I said, and I hopped into Claude and I asked it to build me a visual interactive web application that I could host on GitHub Pages that would help me describe and understand more about technical debt. I just wanted to share that, I guess, as a little bit of a tip on something I've figured out lately that's really been helping me with a number of things. I won't go into some of the other apps. I invite you to go check out my repo and go poke around in there, because there's quite a few of them that I've done similar things where it's a topic that I'm just not super familiar with. But rather than going and spending a whole bunch of time reading Wikipedia and Googling things, I take a new approach where I have a conversation with an LLM to learn a little bit more about it, and then I ask it to build me a web app to help me visualize and educate myself on that. And then I host it as a GitHub Pages in my GitHub account, and it works great. And yeah, I just wanted to share that with you. So that's pretty much all I've got for today. Just wanted to talk about technical debt because I think it's super important. I don't think a lot of us are thinking about it. I think also that we can get hung up in all of the different causes that we hear about that's causing technical debt. But in my mind, it's actually so much more simpler than that. It just has to do with making adjustments on the spectrum between speed and cost and security. And then also now we have to think about maintainability and scalability are two others too. And then the Gen AI stuff is also starting to introduce maybe new vectors of concern when it comes to technical debt too. So I'm, not done thinking about this. I think this is something we have to continue talking about and thinking about to make sure that we're building safe and secure and maintainable and scalable systems. And that's all I'll say about that today. So thanks for sticking around, and we'll see you to the next one.